Okay class, we're looking at complex numbers. This is the fourth video, and this time we're going to be looking at the division of complex numbers. But before we get into that, let's come back and check your knowledge and understanding on multiplying. This time we're multiplying with some irrational numbers, so we've got some surds involved in there as well. So the first example here, when we multiply again, double brackets, we expand using a FOIL method. And so you obtain that, and here it is, there's that I squared, so that is replaced with a -1. And it becomes a +2. And our I terms, we've got 3√2 plus 2√2 gives us a 5√2 altogether. And then adding the real parts gives us this as a complex number product. Let's try the next one. So expand again using a FOIL method. And so that's the first term, √3 on 2 multiplied by √2 on 2, but don't forget the negative. And then the next term is √3 on 2 multiplied by -√2i, gives us that. And then term number 3, this time the √2 multiplied the √2 here in the numerator, and it gives us a whole number 2 here. And then the last term, there it is, there's that I squared. Okay, and so let's collect our real part and our imaginary parts. That's better. And so here we've got a real part and we've got the imaginary part, and one good thing to do with our each surd is to form it with a common denominator. So I might write this 2 with a denominator of 4, and I can express it just like this, and we have our complex number in surd forms. So an important thing to keep in mind there is okay, now let's try some division. So when we perform this division of complex numbers, what we have to do is rationalize the denominator, just like we did with surds. And this is the idea of multiplying by the complex conjugate as a fraction on top of itself, so it has a value of 1. Okay, so the first one is like this, so that fraction has a value of 1. 3 plus 2i is the complex conjugate of 3 minus 2i, and now we treat it as bracket multiplication, so 1 times the numerator, and then in your denominator here we have, think of it as a double bracket, and fortunately it's in the structure of a difference of 2 squares. So it's the same as the first number squared minus the second number squared. And this part, this 2i squared, goes nicely to a 4, positive 4 here. And we get denominator of 13, so 3 on 13 for reals and 2/13 for the imaginaries. Fantastic. Let's try the next one. Multiply by the complex conjugate of the denominator. And here we go. So we have difference of 2 squares in your denominator there. And with the numerator we go ahead and expand the brackets to both sides. Yep. Now have a look, there's an I squared term popping up there, so it's going to be a -1. 9 plus 25 gives us our 34. And now our positive 20i squared turns into a negative 20, and it is a real number. Okay, let's try the next one. So multiply by the complex conjugate. This time the negative 6 plus 7i, and the conjugate is negative 6 minus 7i. And this gives us two double bracket expansions to do with our complex numbers. So let's do a FOIL method when we expand. We know the denominator is nice and easy, so it's a difference of two squares. So there's our four terms. There's the I squared, and we know I squared is negative 1. Collect the real and imaginary parts, and we get negative 33 plus 4i on 85. I think we're going well. And we can break that up into the real part and an imaginary part. Last one. Now we got a bit of a little surd involved with the complex numbers. Let's see how we go with this one. Multiply by the complex conjugate on top of itself. Very good. Now expand double brackets. There's the difference of two squares in your denominator. Careful with your surds, and we should get something like that. With the I squared at the end, don't forget that. Difference of two squares in your denominator. Okay, collect your real and imaginary parts. So that's the real part first, the 2 root 6 minus the 2 root 3 there. So there's the real part, and the imaginary part. Haha. Very good. And we're just dividing by negative 1, so that's going to swap the signs. So it's going to give us something like that. And we can just swap the signs, swap the numbers around there with different signs. Fantastic. So how'd you go? Well, that was done well.